Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, ready to dive into a new project, and I've taken some of y'all's advice of doing what I want to do. I know there's some things that I've kind of left hanging on the channel, but this excites me, and I just want to build this. It got all the parts here. I mean, I wouldn't have bought this stuff if I hadn't wanted to do this. So I've got a Hammond 302AX, which is a really cool transformer that's designed exclusively for use on a 2A3. And it's got a pair of center tapped 2.5 volt windings, so I can use the AC heaters, which is going to be awesome because the 2.5 volts, you don't have to worry about DC. It's also got the winding for rectifier tube, for the driver tubes, for the B+, everything all in one transformer. So it's really going to simplify this build, especially not having to deal with DC heaters, because I've done 2.5 volt tubes before. These 47 pentodes or 2.5 volt doesn't hum at all. So I know I can get away with AC heaters on a 2A3 tube. And then got Hammond choke here. I've actually got a slightly different Hammond choke. We might try dealing with or going with a really low DCR power supply, mainly because I want to keep the B+ up, and that'll help not having, a lot of resistance in the power supply, being able to get high B+ out of this transformer. And then these I got on eBay, and I don't think they've ever been hooked up to anything. They look new. These are a pair of Haber 20 watt 3.2K single-ended output transformers that they only have two primary wires, so they're made for triode. There's no ultralinear tap, or I guess you could do a pentode. But anyway, we're going to be using it with the 2A3. I think a 3.2K could help a little bit with the distortion because it's going to be a little lighter loading on the tube. And again, we want to try to get the bias point to be optimized for using these transformers. And again, I found these on eBay. Somebody was just doing a fire sale, and they had a bunch of transformers. They were just let them go. And I think they even had a make offer, and I made him some silly offer, and he took it. So I got these cheap and never used any Haber. Well, I have used some Haber wound iron on those ST70s, and so I think these are going to sound really good. I've got a chassis here that I can use. I'm probably going to put this thing on a fairly large chassis like I would a 300B amp instead of the smaller one that I do my EL34 on. I think it's a 13x17, which it's not giant, but it gives you a little more room to kind of keep things, away from each other, and especially keeping the power supply away from the driver tubes. And so, yeah, I think this is going to be a fun little project. So in this first video, I'm going to just kind of show you the thought process on how I'm going to lay all the parts out for this build. And I don't think that I'm going to do like this big fabrication video. I may show y'all how to do some of the, the layout stuff and that thing, but I think I'm going to do a lot of the hole punching and all that stuff off camera just so I can kind of knock this thing out, because it does slow things down a lot doing that. And then I can show you how to do the point-to-point wiring on the inside, that sort of thing, and where the wires all go if you do want to try to copy this yourself. And I think it's just going to be a fun project. So let's get busy laying this thing out. Well, here we go with our 2A3 amplifier layout, and I've decided to do a design that does a SRPP 6SL7 as the driver tube, and then we're using these Horizon 2A3 tubes. And I've also got some Shuggy Treasure 2A3s, and I've got several other 6SL7s, but I wanted to lay it out using these Coke bottle ones, so make sure we have plenty of room. And as in most of my amps, we have the power supply like all the way over here. And we're going to be using this 302AX power transformer, 193H 5 Henry choke. We may actually put another choke on the inside. I've got these chokes here that are left over from doing the Wilsonton amps, and they weren't enough current to deal with 4 KT88s, but they should be plenty for doing a 2A3 amp. And they're rated at 3 Henrys at 180 milliamps. So we may end up putting one of those on the inside too. And I've got another choke, a 193K, which is a little lower Henry, but it's about half of the DC resistance. And we can also play around with different rectifier tubes. Initially, I wanted to use these 5V4s because they have the same Coke bottle shape as the rest of the tubes. I thought that looked really nice. Gives a slightly lower B+, but if we need to fudge it up a little bit, we can put a 5AR4 in it. So we got some options on rectifier tubes. Gonna put a vent here to vent this area of the chassis over here, and we're going to put a vent here, and the cathode resistors for the output tubes are going to be underneath this vent to let the heat come out from them. The 2A3 is going to be running AC heaters at 2.5 volts, and so I've got a couple of 10-turn hum pots ordered, and we're going to put one here and one here, so should be able to access them without burning your hands, and it's not something you have to adjust very often. And so I was going to kind of put them back here out of the way. In the front here, I'm going to put some kind of a meter. I'm not sure. I may just put a voltmeter up here, and I think I've got some 0 to 50 volt meters that would work really well for this amp. And then I can just put the meter across the cathode resistor and have a center off switch like this that would switch between the two tubes, so you can get a measurement on the cathode just to check the life of the tubes. This isn't a fixed bias amp, so you're not going to be tinkering with the bias, but it is nice to be able to see how well the tubes are holding up, and if there is an issue where the amp's not performing like it should, you can check the bias really easily. Plus, it kind of fills in this space right here that's kind of blank, given that this is a fairly wide chassis. And unfortunately, Hammond doesn't make something like a 15 by 12, which would be perfect. But the 17 by 12 is not far off, and it is like an in-stock chassis that I don't have to have custom folded up or stamped out and then powder coated. So that's going to save a lot of money. And this is likely going to be the same layout that I'm going to be doing for the standard 300B amp that we're going to be doing after this. I've got the transformer ordered for it, and got some more of these 17 by 12 chassis on the way. So after we knock out this 2A3, we're going to jump on doing that standard 300B amp. And like I said, probably going to be a very similar layout. So, yeah, here we go. So I have finalized the schematic I want to use for this 2A3 amp, and I know there's a zillion different ideas on how to do a 2A3 amp. There's the Loft and White direct coupled, where they direct couple the driver tube to the output tube with no coupling cap. The problem is I've only got probably about 320 volts of B plus to work with this transformer that Hammond kind of pre-selects the voltages on. And it's a 600 volt center tapped high voltage, which by the time you run it through a full wave rectifier tube, you're going to be down about 320, I think. We'll see, but doing the initial simulations on PSUD2, that's what it's showing. And so I'm assuming that's where we're going to be at. And this JE Labs SRPP schematic is calling for 325 volts. So we should be right on the money with that. The output transformers are a little lower impedance than you'd normally use with a 2A3. They're 3200 instead of 2500. And if anything, gonna get a small amount of power reduction, but a correspondingly larger reduction in harmonic distortion. And so I think these are going to work fine. And I've got these just sitting here that need a home. And it's one of the reasons I'm building this 2A3 amp is I realized I've got power transformer, output transformers that have to be used with a triode. They're a little lower resistance than I'd like to use with a 300B amp. Plus, I'm not sure that I can get more of these. And musical power supply is winding me up some custom transformers for the 300B amp, which obviously they'll be able to do more of if somebody wants to buy my standard 300B amp after we finish the prototype. And again, these little meters, I'm not super crazy about how they look. I do have a punch this size so I can recess these and mount them from the back. And so that should make it look better with just the bezel sticking out. I'm just not crazy about them being plastic, but I just don't see anybody that's making a like metal rim, high quality looking voltmeter that are under like $300 a piece. And we can't do that even on the higher end 300B amp. So really appreciate it if any of you guys know of a source for nice voltmeters that aren't these, $5 made in China ones. That would be great. But I noticed that other boutique manufacturers that put meters on their amps are using these same little made in China ones. And so that's probably what we're going to end up with. Anyway, let's go look at the schematic and see how that all lays out, and then I'm going to go fabricate this up off camera. I've done enough fabrication of chassis and stuff online so that you could see them, and it really slows down the process, and I need to knock some of this stuff out. And so, yeah, we're going to do the majority of the fabrication offline. And the other thing to note, I'm using these larger rings around the 2A3 tubes. We're going to drill vent holes around between the tube socket and this ring to give ventilation that'll come up past the tubes and help keep the tubes cool. So that's one of the features that we're going to be doing. And I did space this transformer over a little bit so we got a nice pathway for the RCA terminals and the shielded wires that are going to come up to the front end tube where they can kind of go around this outside and they'll be away from the transformers. Plus, I think it just kind of gives it a nice symmetry on the way it's laid out. So, again, I've talked about this in other videos, but in case you've never seen those, the way the transformers are laid out is very intentional. We've got the power transformer turned 90 degrees from the output transformer, and that keeps the flux leakage out of the laminations from interacting with the output transformers. And then we have the choke as far away from the power transformers we get it, also turned 90 degrees. It's also far away from the driver tubes and anything that it can interact with. Same way we have the output transformers rotated where any flux leakage that comes out of the laminations, which will come out in this direction, don't interact with the tubes. Not as big a deal with these direct heated triodes, but it can be a problem on the beam pentodes where it can distort the electron beams inside the tube if you have the transformer windings or the laminations aimed at the tubes. And so just a good habit to get into. And then you can see we've got a nice big gap here between the power supply and the output transformer and any of the tubes so that all the AC noise stays over here. It's really important, especially on something like a 2A3 amp that has very low power, that we're not going to be able to tolerate any hum or noise. And so we need to make sure that everything is laid out to be as clean as possible. So let's go in this segment of looking at the chassis layout and dive into looking at the schematic and the reason I chose it. Okay, so after doing some research and looking around, didn't see any point in reinventing the wheel. And so this JE Labs design came out at least 25, 30 years ago. And a lot of people have built them. People are really happy with them. I like the idea of having something a little more stout than just a single triode driving this triode. And they do have another design that parallels the two triodes in a 6SL7 driving the 2A3, and it's called their simple design or simple 2A3. But I like this SRPP design. So what we've got going on here is, here's our B+, and like I said, this is shooting for in the 320, 325 range, which we should get with that Hammond transformer. So it comes into the output transformer, comes over to the plate of the output tube, and his designs don't draw a circle around the tube, which to me makes it a little harder to kind of figure out what's going on. But this is the plate, that's the grid, that's the cathode. This is the tube, the 2A3. So 318 volts or so on the plate. We've got a 75 ohm resistor, a 2 watt he's calling for. I found a 100 ohm 10 turn pot, which will work fine as well, that we're going to put across here. And we'll see about 47 volts, 45 to 47 volts here. And then I'm going to use a 750 ohm resistor here to run the tube a little hotter, trying to get a little more power out of the amp. A lot of 2A3s run at this 320 on the plate with a 750 ohm resistor on the cathode. So that's what I got. And trying to find 880 ohms, there's really only those chassis mount type. And I wanted something that was more of an axial type resistor that was designed to run at high wattage without having to be bolted to the chassis. I'm also going to run about a 10 watt resistor. There's no reason that it needs a 50 watt resistor in this location. So we'll go over the parts when they all get here. We're going to have a 100 UF cap, and here he specifies using something like a Nikon Muse, and I've got some of those, so that's likely what we're going to use in the cathode bypass position. 470K grid leak resistor, which puts a really easy load on the driver tube. We're going to be using a 0.22 UF aluminum oil cap in this position, one that you guys watching the channel know that I love the way those sound, so we're going to be using one of those here. Let's follow the driver tube. We've got a 27K resistor here, and then he's calling for a 20 UF Solene cap, which they make those 22 UF caps, but they're really giant. So we may, for cost reasons, use something like a 27 or 33 UF electrolytic cap here for the power supply to the front end filtering. Going to have 300 volts at the top of our little totem pole here. And the grid of this top tube is fed off the plate of this bottom tube. And then we have this 2.2K resistor to bias this upper tube, so that we have a higher voltage here than we do here. So that's going to bias this tube right at 2 volts. And then this tube feeds the plate of this bottom tube. And then this bottom tube is going to have, like here it shows here, about 146 volts. Again, it just needs to be a couple of volts lower than on the other side of this resistor. And then he's showing another 2.2K 1 watt resistor on the bottom with another 100 UF, a lower voltage cap here. The other thing that we can experiment with, since it's 1.6 volts, is putting an LED across here with a small resistor to tweak the voltage up to 1.6 volts. But we may try it both ways and do one channel one way, one channel the other, and then listen to them. And that's one of the good things about having my mono cartridge and some mono recordings, is that you can compare like the left channel and then the right channel, and they're going to sound the same and normal, and you can actually compare one channel to the other using a mono recording. And then here in the front, 100K log taper potentiometer that will control the volume. I actually have some of these Alps pots that I need to use up, so we may actually just use an Alps pot here. And then again, he's showing that he's using an Audio Note 2.5K, whatever this Experimenter series output transformer. We're going to be using a 3.2K that has a single 8-ohm tap. And he's talking about using Allen Bradley, carbon comps, and that sort of thing for these resistors. We're probably just going to use those 2-watt Vichy metal film resistors that I know are really quiet, given that we're trying to keep the noise floor on this amp as low as possible, because I'm going to assume most people that would use an amp like this are going to be using it with Clips, Heresies, or something that's going to be super high efficiency where they can't tolerate any noise. So anyway, this is the schematic we're going with. And like I said, there's a zillion different 2A3 schematics, the monkeys and the Lofton Whites and all these different ones. And this just looks like it'll fit what we want to do. It's going to be simple to wire up, as you can see. It's just some jumper wires across these tube sockets. Another reason to use an octal socket is it gives us a lot of working room around the tubes, which is a lot easier to deal with than the little 9-pin guys. And I've seen a similar schematic like this using a 12AU7 or a 12AY7, and I decided to go with the 6SL7, mainly because I've got some of these tubes. I think they'll look better than having a little tiny tube driving a giant tube. And yeah, I just like the look of the schematic. I think this is going to work good. So, looks like a good place to wrap up this video. Well, as you can see, this is a pretty simple layout. And I know some of you are going to go, it's going to get all your amps look like that. And it's, why reinvent the wheel? I know this layout works, and I know this is quiet. And I really like putting some distance between the high voltage AC and the low voltage signal. And like I said, I just know this works. Stick the rectifier tube here, power tubes here, signal tubes up here in the front. It's going to work. And I like having this larger chassis because it gives you some room to work inside of it. Makes it so much easier to connect all the wiring and stuff. And yeah, I think this is going to work out really good and be a pretty quick, easy build. The only thing I'm going to ask you guys, because I've got a lot of people following my channel, a lot of y'all watch my videos, I want to find a nice looking 100 volt meter to put here to fill in this space kind of between the tubes and the choke that I could use for checking the bias on the output tubes. And I know with a cathode biased amp that you don't really have to do that very often, but it is nice to be able to confirm that, hey, you switch the switch one way or the other, look at the meter and you go, yep, bias looks good, let's rock and roll. And then it's not in the circuit when the music's playing either. You can just switch it in and out. And I don't even want to put like a milliamp meter, in line with a signal, because then you've got the signal going to the meter. That's never a good idea. And so I've seen the little $5 China ones. I used to use those. Yashimoto made a really nice one, and they don't make them anymore. And so it doesn't necessarily need to be that nice. And I may try to find some older vintage one. But yeah, if you guys know where there's a nice looking metal, preferably bodied meter, or at least got a metal trim around the edge kind of a thing, put it in the comments and help me out. Help me find this thing. I mean, I've searched online and I haven't had any luck. And maybe one of you guys has seen something really cool. So anyway, I think I'm going to do that dark bronze hammer finish paint on all this, so all this stuff matches. May end up painting the lambs on this black because they're kind of ratty looking, and get that looking as nice as these do, and then get my little 2A3 amp built. So anyway, hope you're enjoying this content. If you are, please subscribe to the channel. Please like the video. Thanks to all you Patreon supporters and folks that have joined membership on the channel or made donations at my website if you found this content useful. And just appreciate all you folks that have subbed and subscribed. We're approaching 20,000 subs, which is awesome. And hope to hit that this summer. Maybe this 2A3 build will get us there. And until the next video, have a nice day.